My dear students, let us understand about OOP. What is the meaning of this OOP? Why do we use this OOP concept in our programming? So the full form of OOP is object oriented programming, right? In simple words, it's a approach or a concept or a way which we use in our programming question or programs, right? So before proceeding, I would like to tell you whatever program we write, okay, either it's of one page or more than one page. So in each program, there are two very important things, okay. The first one is data and second one is functions. Whatever program we write, okay, every program will have the data and functions. Program is set of instructions, okay, which we give to the computer system, okay. I hope it's clear. Now the question is, why do we use this OOP concept in the programming, okay, or especially if we talk about the Java program, okay, Java programming questions. So my dear students, what happen, what we do, we divide our problem into number of objects, okay. And see here, suppose this is object 1, this is object 2, this is object 3, right? Now every object will have the data, right, as well as function. This is the characteristic of object. Now dear students, every object will have the separate copy of data. This is a very important thing in OOP. Every object has a separate copy of data, but each object share the functions, okay. This function, whatever functions we have, these functions will be shared to each and every object, okay. So this is the advantage to use the object oriented concept in our programming approach, okay. And what it is doing here, it is stopping the flowing of the data globally because it is attaching to the object. It stops flowing the data globally, okay, in the program, right? So it's solving our big problem. Now this OOP is having some principles. First one is inheritance, second one is encapsulation, third one is data abstraction, and fourth one is polymorphism. So my dear students, all these four principles we use to write our programs, okay. All these principles we implement in our programs, okay. I hope it's clear. So what is the role of these principles? So I would like to tell you in simple words, these principles makes our programs very effective, okay. Effective in the sense of accessibility, accessibility of the data members as well as functions, okay. So I hope it's clear to you. Let us understand these principles one by one. So first of all, let us understand the encapsulation. So dear students, as I told you, whatever program we write, either it's of one page or more than one page, we will have data as well as functions, right? And you know very well, if we consider a specific language, for example, Java, so we start from class. We write class name, for example, A, and we describe the data members and functions of the objects. Okay, so my dear students, where we are grouping these data members and functions inside the class. Okay, inside this braces. Okay, that means these are grouped into a single unit, and this single unit what we are called class. Okay, so this is the example of encapsulation. Okay, so usually whenever we write the Java program, this principle is implemented and automatically implemented, because without class we can't write a Java program. Okay, and if I tell you the second principle, let us see about inheritance. So dear students, what happen in inheritance? You know, in a program, right? We can have more than one class, right? So suppose this is class A, and let us consider there is a class B. Okay, so if something we have described here, data or function, so obviously you know very well, it's not worth if we describe same data member and functions in this class, because we have already described, we have already declared, right? So what is the best way? The best way is to use this data and functions which we have already described or declared or defined, to use it another class or somewhere else. Okay, so this makes this makes our program very effective. Okay, now inheritance is the process in which the data members or functions, as well as functions, or we also call it the properties, okay, of this class links and shared with the another class. Okay, by extending the class. How we extend? By writing the keyword extends A. Okay, let us see the next one, next principle, that is polymorphism. So in polymorphism, what happened? We can have uh, one form, or we can have one thing for many purposes. Okay, suppose very simple example we will consider area. Suppose we would like to calculate the area of different figures. Okay, so definitely if we are having three figures, so we will have to write for three times, right? So you can see here one thing we are using for different purposes. Okay, so let us consider this is the for the circle, this is for the triangle, this is for the square. Okay, so this in this way we implement the polymorphism in the programming. Okay, so dear students, you might have a question: how compiler will know about these all functions, or how compiler will know about this is the function for the circle? Okay, so dear students, in this case what happened? Compiler will differentiate on the basis of two conditions. First one, number of parameters, and type of parameters. And my dear students, parameters are those variables which we pass here. Okay, we call the parameters, right? So this we will discuss in later videos. Okay, I hope it's clear to you. The last principle is data abstraction. So in data abstraction, what happened exactly? In case of data abstraction, we just provide the essential details to the user. Okay, so for this case, we write the abstract methods in Java programs, right? And dear students, we can also apply a data abstraction if we do not implement the methods or functions in one class. Okay, but we can we can declare those abstract methods into the other classes which are not accessible to the user. So that is the example of data abstraction. Okay, you might also think like that. Suppose we are having the TV. So in case of TV, my dear students, what happened? We just watch the picture, right? Video. Uh, so dear students, we are not caring about the internal part of the TV. What kind of circuit we are having inside that body, right? What kind of cabinet we are having, what kind of wires we are having. So this we do not care about that. Okay, so this is the example of the data abstraction. We just provide the essential details to the user. Users just watch the TV and that's it. Okay, so I hope it's clear to you. So thank you so much. Thanks for watching.